My name is Steve. Welcome to my shop. First of all, I'd like to thank all of my new subscribers. Since the Brass Hammer giveaway, we picked up 40 subscribers during that period. I want to thank all my current subscribers and the new subscribers and all of you that entered into the contest. I have a video posted showing the drawing and the winner. The winner's hammer has been mailed out. It's on its way to Anchorage, Alaska. Project that I'm working on today is for a friend of mine who's a musician, and this is a headless guitar. I don't really know too much about guitars. I've played a little bit of acoustic. I don't know anything about electrics. I don't know the make of this or anything else. All I know is that he plays it in a couple of bands. Apparently it has some kind of a unique sound that they really like. And it's got a problem. The tuning on this is done by these screws down here. A normal guitar would have the tuning machines, or whatever you want to call them, up on the head. This just has a bracket that holds the strings on the top. It's got this wedge piece, and then there's another piece that goes on top of that that screws down. There are 6 set screws that go through it to hold the strings. I'll show a picture of the close-up of this in a few minutes. And this piece has stripped out between 2 of the holes. It broke the web between them. In addition to the 6 set screw holes for the strings, there are also 3 mounting holes. And each one of the mounting holes goes between a pair of the strings, and it makes that web pretty thin, and it broke. So this piece is about 1 5/8" overall length. It's just over 1/2 inch wide, and it's just over 3/8 of an inch tall. Originally made of brass, and I've chosen to make it out of a piece of stainless steel. I got a piece of 5/8 stainless steel that I'm going to use to make it. And the reason that I chose the stainless is, for one, so that we don't have to go out and get this chrome plated. The stainless, I'm just going to polish it up, and I think it'll look pretty good. Plus, I think it's going to be a little bit stronger than the original brass, and really shouldn't affect the tone any. So what I'm going to do, I'm going to show you a close-up of the damage that was done to this, and then we're going to get started. As with most projects, you start at the bandsaw. Here's the piece that I have to replicate, and you can see over here on this side where it broke through the partition between the holes. The 6 set screw holes are 4 mm, and the 3 hold down holes are 3 mm. And then there are 6 slots on the bottom of this for the strings, and they are varying widths. From the narrowest up at this end to the widest up at this end. Well, I've got to mill those in. Because of the anticipated difficulty of threading this piece, I'm going to take and cut it. I'm just going to mill it to rough size, And then I'm going to do all the drilling and threading before I do any of the finish bevels or anything on this, just in case I break something. I won't have to lose all that machine time. So let's go over to the bandsaw and get started. First thing that I'm going to do is square off the end, and then I'm going to finish off the length of it. I'm using a 3/8 inch Niagara carbide end mill. The overall length is 1.655, and I've scored it just to have a mark to aim for, but I'm going to measure it off to get the final dimension. Okay, I'm at 1.690 right now, so I'm going to creep up on it 10 thousandths at a time. Okay, I am at 1.665. I got 10 thousandths to go. 1.654 or so. Should be just fine. The finish height is about 355, but I want to leave myself some a little bit of room for filing and polishing the top of it, and that dimension isn't critical anyway. I just want to leave myself a little bit of room. Getting pretty close to my vice jaw there. I want to check, make sure I'm not going to hit it. That's as far as I can go. Made it. Okay, for the width, I'm starting out at 625. I need to end up at 555, so I got 70 thousandths to take off of it. There's 10, there's 20. Okay, I'm at 560, so I've got 5 thousandths to go. It's 555, right on the money. So I'm going to take it out of there, deburr it, and lay it out to start drilling some holes. One of the things that took the most time in planning this was to get the spacing on the holes set up. So I started out with number 1. I'm using that as my reference at 0. And so I took and I threaded a couple of the 4mm screws into the piece, and then I took and measured across the two. I subtracted the diameter, and I came up with the total length of 1.385. Divided that by 5, and then I went and accumulated from 0 up to the 1.385. Then I need to put the 3mm holes in, which go in between. It goes in between here, here, and here. So I split the difference between them for that dimension. And since I haven't gotten the DRO installed on my mill yet, I've got to do this by the manual method. So I've already done and spotted number 1, and I moved and spotted number 2. So now I'm going to continue on and spot drill the rest of them. I went back to 0, and let's try this again. Each revolution is 125 thousandths. Ah, that's where I went wrong. So there's 125. There's 250. There's 375. Okay, there's 500. That's 505. 515, 25, 35, 45, 54. Okay. That's it. Right on the money. Okay, my next dimension is 831. I continue on and do the same thing. I've got 6 more holes to spot. Now, in order to zero out again, what I did is I made a mark on my bed I go past it, take out the backlash, and when I come back here, as this begins to line up, I go back to 0 on my dial, and I'm right back at my home position. And now I'm going to go forward and drill the or spot the 3 holes for the 3mm. So I'm back at 0, which is the first hole, and now I need to go 138 thousandths for the first of the 3mm holes. So 1 full revolution is 125 thousandths. So there's 125. $30, $35, $138, and that should split the difference between the 2 holes, and that looks right. So now I just have to do that 2 more times, and I've got all the holes spotted. Since I do a lot of modeling and small work, I have pretty much a full set of ER16 collets. So I'm using them to hold my drills. And now I've got to change out my spot drill for the tap drill. I'm going to start by drilling the holes for the 4mm. Just tighten that up in the collet. Go back and line up to my 0. Take out the backlash. So I'm back at my home position at 0. So use a little bit of anchor lube here. Okay, I've got to do that 5 more times. Come back when I'm finished. My experimenting before I started actually making the piece, I found that the anchor lube was the best product that I had. So let's go for it. Well, I can see this is going to take a while, so I'm going to turn off the camera and we'll come back when I'm done. Now, this is the last hole that I have to tap. This one's a 3mm. I'm using the anchor lube, and since it's water soluble, I diluted it a little bit, and I'm finding that that's working much better. I ran into some trouble with the hardware grade taps that I had, so I ended up ordering some new taps from McMaster Car, and I got the machine taps, and since I'm doing through holes, I did the tapered gun style taps for tapping a through hole, and these things are going through as if I was tapping aluminum. They're just great. Well, that's it. I'll clean it up and get it ready to mill it down to the final shape. So I think I'm going to wrap this video up at this point. I don't want it to run too long. So in part 2, I'll reshape it and install it on the guitar. See you next time.